Hello, geometry students. Part 8 of the video is going to go through questions 1 through 6. That's the front page of the review. And then the back page of the review is going to be on part B of the video. Now remember, I want you to try all of the problems first before you watch the video. Don't watch the video as you're doing the problems. That's really not going to help you that much. So for part A, find the missing side of each triangle. Leave your answers in simplest radical form. We're going to start with our Pythagorean theorem. A squared plus b squared is equal to c squared. We're solving for a leg, so that's either A or B. The 34 is the longest side, so that must be the hypotenuse. X squared plus 13 squared is equal to 34 squared. So I have x squared plus 169 is equal to 1,156. Subtract 169 from both sides, and I get x squared is equal to 987. To solve for x, I square root both sides. I don't know a perfect square that divides evenly into 987, so my simplest radical form is actually x is equal to the square root of 987 units. I start out the second problem the same way. A squared plus b squared equals c squared. Again, the 10 must be my c. 2 root 15 is a leg, so it can go in for either A or B. I'm going to put the 2 root 15 in parentheses to remind myself that I'm squaring both the 2 and the radical 15. So I have 60 plus b squared is equal to 100. Subtract 60 from both sides, and I find that b squared is equal to 40. After I square root both sides, I don't know the square root of 40, but I can break it up into radical 4 times radical 10. So my final answer is 2 root 10 units. Number 3, a squared plus b squared equals c squared. Remember, it's always good to start with your original equation. Plug in radical 2 for b and plug in radical 6 for c. So I have x squared is equal to x squared plus 2 is equal to 6. Subtract 2 from both sides, and I find that x squared is equal to 4, and x is equal to 2 units. Some common Pythagorean triples are 3, 4, 5, 5, 12, 13, 7, 24, 25. Remember, the definition of a Pythagorean triple is whenever the three side lengths of a right triangle are all integer numbers. To show that it's a Pythagorean triple, you could show that 3 squared plus 4 squared is equal to 5 squared. So it is indeed a right triangle. And remember, any multiple of a Pythagorean triple is also a Pythagorean triple. So if I took the Pythagorean triple 5, 12, 13, and multiplied all 3 of them by 2, I could find another Pythagorean triple. Number 5, state whether each triangle is right, acute, or obtuse. The rule is, if c squared is equal to a squared plus b squared, the triangle is right. If c squared is greater than a squared plus b squared, the triangle is obtuse. And if c squared is less than a squared plus b squared, the triangle is acute. And I put a reminder here. Remember, the longest side must be c. My side lengths are 4, 4 root 2, and 6. If you're not sure which one's the longest side, just plug 4 times the square root of 2 into your calculator. We find that the longest side is 6, so that must be c squared. I'm going to see if c squared is indeed equal to a squared plus b squared. So we have 6 squared is equal to 4 squared plus 4 root 2 squared. Does 36 equal 16 plus 32? Well, no, it doesn't. It is less than. So the triangle is acute. My second problem, my side lengths are 27, 6, and 30. Again, remember, the longest side must be c squared. So I'm going to plug in 30 for c. Doesn't really matter which one's a and b. 27 for a and 6 for b. 30 squared is 900. 27 squared is 729. And 6 squared is 36. And I find that 900 is greater than 765. So this is an obtuse triangle. For my last one, we're going to see if c squared is equal to a squared plus b squared. My longest side this time is 2 root 7. So I'm going to plug 2 root 7 in for c. Root 7 for a squared, and root 10 in for b squared. 2 root 7 squared is 28. Remember to square the 2, and then whenever you square a radical, the radical and the square cancel out. So I have 4 times 7, which is 28. And is that equal to 7 plus 10? Well, no. It's actually greater than. So this is also an obtuse triangle. Number 6, a rectangle has a perimeter of 20 and a width of 4. Find the length of its diagonal, and they tell you to draw a diagram. So I'm going to draw my rectangle with a width of 4. Remember, using your properties of rectangles, sides opposite each other have the same length, so this side must also be 4. The perimeter, all 4 sides have to add up to 20. So far, we've used up 8. So we have 12 left for the 2 sides, which means that each remaining side must be 6. They want to know the length of the diagonal, so let's actually draw the diagonal in. And you notice that we've actually formed a right triangle. To solve for the missing length in a right triangle, we use the Pythagorean theorem. A squared plus b squared equals c squared. Since the diagonal is the hypotenuse, we're actually solving for c in this equation. 16 plus 36 is equal to c squared. So c squared is equal to 52. And then to solve for c, I take the square root of both sides. I don't know the square root of 52, but I can break it up into radical 4, radical 13. So my final answer is 2 radical 13 units. Part B will have the back side of this review.